then there's how they get into this groups. Now, do they get randomly allocated, or do they get allocated by measurement? And this was the question that you asked, Jane. And I think what Jane was talking about is, okay, they might be smokers and they might be non-smokers, but and you find the relationships between smoking and disease. But is it the smoking, or is it something else about smokers? Is this the point you're raising? Yeah. And I think this is really, really important. And if I digress slightly so alcohol, light to moderate alcohol consumption, and coronary disease. We all know that red wine's good for us. So I, as part of my PhD, one of the things I measured, halfway through the study, it was a 2-year study, and halfway through the study, a paper came out on the relationship between alcohol and coronary disease, that it was protective. We thought, God, we should put some questions about alcohol into the study. So we were able to do this. And so for the second half of our study, we measured alcohol consumption. And at the end of the study, smoking was the worst thing you could do to yourself, but the best thing you could do was to drink light to moderately. Or even, and that was only from doing it for one half of the study. It was the most powerful protective effect we found. So,
should that be discrepancies?
Yeah, so I was going to come to that. So for about 10 years, and I started looking at the literature because initially I was, wondered how real it was, and I became convinced that that light to moderate alcohol consumption was good for you. It was good for you, and I wrote a number of papers, and I used to get invited to meetings all over the world. Not as interesting. Well, interestingly, of all of the meetings that I attended, there was only one that I knew was funded by the alcohol industry. And in fact, the only reason why I agreed to attend the one that was funded by the alcohol industry is because the most famous epidemiologist in the Western world at the time had agreed to speak, and I was asked to speak on the same podium, and he was highly respected. I said, well, if he's going, I think it's probably okay if I'm going. But anyway, so the story goes like this, is that so I was speaking at these various meetings, and then I got asked by ACC if I would lead a group to look at the burden of alcohol-related disease, not just coronary disease. I mean, we were convinced that alcohol in heavy consumption caused all sorts of other things. And so I started re-looking at the literature again, and it was with a bit of space. And in between when I'd done my own study and when I was asked to re-look at the literature, there was a very famous study that many of you might know about. It was a randomized controlled trial of hormone replacement therapy for women post-menopausally. So up until the 90s, most people believed that women who took HRT postmenopausally had a much lower risk of coronary disease than women who didn't. And in the 90s, someone did a randomized trial. So the studies up until then, menopausal women or postmenopausal women, asked them, do you take regular hormone replacement therapy? Yes, no. And then follow them up over, say, 5 years, and they found that the women who took HRT on a regular basis had half the risk of coronary disease as women who didn't, in a cohort study, non-randomized study. And then someone thought, look, part of that might be confounding. It may be that part of that is because the women who take HRT are more motivated, interested in their health. So everyone was convinced that it worked. But they were not certain about how well it worked. And so they did a randomized trial. Zero benefit. Zero benefit for coronary disease. So even though they'd attempted to adjust for all of these other factors, all of their adjustment missed a halving of risk. And what we now believe, it's still kind of contentious, but we went from recommending hormone replacement therapy to women postmenopausally, particularly if they were at high risk coronary disease, to now, if you take hormone replacement therapy during the perimenopausal period, you only take it if you've got significant symptoms, and you should only take it for a relatively short period of time. And so you're doing it despite the coronary risk, because at the time the symptoms of that perimenopausal are more important to you than the small risk of coronary disease. So that's a radical change. But for me as an epidemiologist, having spent most of my early days working in cohort studies, thinking that I could adjust this stuff in the analyses, I could adjust these things in analyses. I then went to do, then I saw this data from randomized trial, and I became far, far more cautious about the benefits. And so I started re-looking at my studies. We did some more studies, and by the end of it, I became convinced that the reason why light to moderate drinkers have less coronary disease than either heavy drinkers or non-drinkers is because light to moderate drinkers are light to moderate people, and they do everything light to moderately. And so if you're a light to moderate drinker, that's fine, but the benefits are because you're light to moderate in everything, and probably have very little to do with the alcohol. And so, fortunately, we were never so convinced that we recommended that people start drinking, and I'm glad that we didn't. Yeah. But anyway, I finally, so when I came to this conclusion, I decided that I had to fess up, and so I wrote a paper to the Lancet that I called "Alcohol and Ischemic Heart Disease: Probably No Free Lunch," and what I basically said in it was that I think that the apparent benefit is confounding. And also, but what is interesting is that if you drink enough alcohol, it pushes your HDL cholesterol up. You're aware of that? So and that's part of the reason I was convinced that alcohol was good for you, because it increased your HDL, and HDL prevents, is associated with low risk of heart disease. But I now think that by the time you drink enough to push your HDL up, you might reduce your risk of a coronary, but you'd be killed by other things. And so I think that if you drink enough alcohol, it will reduce your coronary risk. And people often talk about alcoholics having clean arteries. They're still doing autopsies on them, so they're dead. So the alcohol killed them. The bad news was the alcohol killed them. The good news was their arteries are good. So I basically said I think I was wrong, and I used to get an invitation every year or so, maybe more. I've had one invitation since 2006 to speak at an alcohol meeting. So I'm now convinced that many of the meetings that I thought were funded by universities and I think that a lot of them were actually indirectly funded by the alcohol industry. I was quite shocked, because I specifically didn't go to meetings, except for one, and I was very conscious about not accepting alcohol funding to go and speak about the benefits of alcohol. And so I think there's a really insidious, and I think it's right through everything. So I don't necessarily think that the alcohol industry buy academics and get them to say what they want. They go find academics who are already convinced one way or the other. So I think a lot of the people who you see speaking at meetings about various things that you think, that are supported by industry didn't tell them what to say. They just found the people who were already saying that stuff. And I think this is what's happening in so many areas, and food is, clearly, is, and it's not just speaking at meetings, is that if I write an article, and in fact that we've got some stuff from the New Zealand Medical Journal, which basically says the experts were right. A high saturated fat consumption increases your LDL, which increases coronary disease. Anything in the newspapers? No, because it's not news that the experts were right. But someone writes an article, the experts were wrong. One, the newspapers like controversy, and it's good to knock experts. Secondly, the food industry will make absolutely certain that paper is on the news desks of every newspaper. and in front of TV. So the industry, not just food, it's drugs. Industry is trawling the journals all of the time. They have these huge PR, these groups, and newspapers now have so little funding that newspapers just sit there and read the stuff that comes to them, and TV and everything. And so even if there's only 1 in 100 experts who believe something, a particular thing, you know, if it's controversial, it'll get out there. We were talking about this earlier. So it's so easy to change public opinion. You know, coconut oil, I talk about, you know, it's saturated fat, for goodness sake. It increases your LDL cholesterol, okay? There's no new evidence that it's beneficial, but the world is now convinced, so many people are now convinced it's a health food. It's going to be, is it the new broccoli? It's a new superfood. And so that's, someone's done an amazing PR, you know, a really PR. And the Heart Foundation have released a review of the evidence, you know, which, but someone is doing an amazing PR job, and there will be an expert somewhere who thinks that it's good for you. And I don't know, you know how people talk about a high smoke point is good? You know, so in one article I talk about a high smoke point. This is a great oil because it's got a high smoke point. But coconut oil doesn't have a high smoke point. But of course that doesn't get mentioned, and I don't know what it is. Anyway, I don't know, I'm sure you all have patients or know people who are convinced that I've changed my life around, I've ditched all that other stuff, you know, the olive oil and safflower oil and the margarine, I just live on coconut oil. One of my colleagues' wives buys it by the 50 kilogram bucket. She buys it by the bucket. I don't know. Anyway, the other thing I was going to say, so there was this confounding. So everyone's now convinced that randomized trials are the answer, that we need to do randomized trials. But randomized trials can be great if they're short, but if you randomize people to one diet versus another diet, and particularly if you're looking at diet and disease, if you're looking at diet and weight, you can actually do a short study. You can do it in 6 months, 3 months, 6 months, 12 months. But if you're looking at diet and heart disease, you need to wait 5 to 10 years. Because, you know, the good news, disease doesn't happen that often. Disease is quite rare, which is why we need to do these huge studies. And of course, if you're doing a 10-year study, people move. People don't stay maintained, so they don't complete follow-up, they're not compliant. And we talk about, you know, like if you put people in a high saturated fat and a low saturated fat group, or high fat and low fat, the people you put in the saturated fat diet won't comply with your, you know, with your advice. And then contamination, they get contaminated by people in one group moving into the other group. Or there's this thing called co-interventions where other stuff gets done, like people start doing other things. So people don't just change from a high fat to a high, or people don't, you know, it's either way. Actually, generally, people don't just change from a high carb to a high fat diet. They often make lots of other changes. They often, you know, I don't know whether you know, there's this guy Grant Schofield who everyone talks about. Yeah. So, I mean, he looks ketoacidotic all the time. I mean, I'm not, you know, I disagree with almost everything. Well, I don't disagree. What he's saying now is that you should eat whole foods. So he's changed what he says. I think that's a great thing. But he eats a very high fat diet and actually doesn't eat very much because he's probably feeling sick all the time. So he has a low calorie, I mean, he's probably having a low calorie diet. But you know, that's why some of these high fat diets, very short term work, because they make you feel sick. Yeah.
I kind of disagree with that.
That's cool. Go.
Because I would say that fat is really satiating. So, and like the studies I've looked at, they'll get two groups of people. The people who are on the low fat, high carbohydrate diet, they control the amount of calories they're having, but with the low carb, high fat diet, they obviously, seeing as they've got lots of fat in there, the calories do bump right up. So it's like these people lose more weight than these people. They haven't controlled the calories whatsoever on these group. They have to keep the. Do you
No, I'm with you, but I think what you're saying is I'm agreeing with you because Grant eats a high fat diet,
and people generally find it really fat is
more satiating. Well, they often get ketoacidotic. So when you say satiating, they feel unwell and they lose their appetite. I mean, my understanding, and I'm not a nutritionist, but my understanding is that protein is the most satiating of the macronutrients. So when people have done studies, they find that protein, and I think fat is the next most satiating, and then carbohydrates, particularly the sugar, the sort of refined carbohydrates or the simple carbohydrates are the least safe. So no, I'm agreeing with you. So I mean, as I said before, I think the evidence is moved in that a higher fat, lower carb diet for weight control is better. No, I think that's right. But I guess what I'm saying is that on a high fat diet you eat less. Yeah, you eat less. So you are
eating less, so you've probably got more calories going in.
Well, you end up with fewer calories, even though there's 9 calories per gram of fat versus 4 for carbohydrate. Basically, the first law of thermodynamics holds is that energy in, energy out. Unless it's being excreted, there's no doubt that if you take something in your mouth and it doesn't get absorbed into your bloodstream, then that's a part of a calorie that's not absorbed. But once it's in there, it's a calorie. There's nothing magic about calories. There are all sorts of other things that happen. So, for example, a calorie that comes from a carbohydrate is more likely to push your insulin up, okay, which then is more likely for you to get a drop in your glucose, which makes you hungry again. So that calorie, that 1 calorie from one source might make you hungry, whereas a calorie from another source might actually satiate you, but that 1 calorie that went in was still a calorie. It's just, I guess that's what I'm saying is that if it gets into your system, it's a calorie, but what that calorie does to your appetite varies, which is what you're saying.
Yeah.
And I'm agreeing. So I think, but what you raise is a really interesting, you raise this really interesting issue that how you describe this can have quite an impact on your advice. So some people are saying, eat fat. Just eat as much fat as you like. And so some people are eating as much fat and reducing their carbohydrates, and they're getting fatter because they're just kind of going to
My understanding of some of the Grant's people is that they're athletes, or they're really very
yes.
He's done studies with real athletes.
Yeah.
And it's kind of like if you deal with horses, you don't feed the race horses on what you feed the hacks that run around the farm.
So there's an issue. Grant is working with people he recruits are because he isn't.
Feed me because I'm not an athlete in that way. I wouldn't think.
Yeah. No, and I think that's another point. So he does work in these high performance group. But I think there is this thing. Calories have different effects in the system. Okay. And sometimes people, so when you hear that statement, a calorie is not a calorie versus a calorie is a calorie, it depends which part of the system you're thinking about. And so what often happens is that people who've been told they can eat as much fat as they like, they forget, but they still eat quite a lot of carbs, but it's like, they eat the fat, It's like I'm eating this carb, and I got to reduce that. So I reduce that a bit, but actually I can eat as much fat as I like, and so they end up actually eating more of everything. But yeah, I think we're agreeing that a calorie from different macronutrients has a different impact on whether you eat another calorie. Is that's kind of what you're saying? Yeah, and I think that's correct. But if you are eating the same number, when you put people in a one of these kind of metabolic ward experiments, is where you basically imprison them. When you imprison them, and you you're in control of every calorie they eat. My understanding is that if you give two people the same number of calories and they eat those calories, it doesn't matter where it comes from, their weight, it doesn't change their weight. It's when you actually give them freedom. So if you feed them a high fat versus a low fat, then it looks like, and particularly in this study, it looks like those who were told to eat more fat and less carbs end up eating fewer carbs, and they lose weight.
I think we also forget to think about whole well-being as well. We're debating all this high fat, low fat, high carb, low carb stuff, but we forget to even just focus on everything else that goes on. We're all focused on weight.
Absolutely. And that's the other issue. So Boyd talks about this conflation. We conflate things. When we see people are getting fatter, and so we think it's all about weight. Now we should be worried about weight, but what about?
Yeah, I mean, you talk about going high fat. Well, do they have enough fibre to protect against bowel cancer? Do they have all that other stuff? And there's studies that show too that if you try and live a healthy lifestyle, the weight will just come off as well, whether you're focusing high fat, low fat, high.
Well, one of the most extreme things, I don't know whether, people are told to eat less fruit because there's this whole fructose thing. Now, I think there's something in the GI thing. I think the glycemic index, so that's the glucose, I think there's something in it. I think that sort of vicious cycle of a high glucose load, getting an insulin surge, and you get plummeting blood glucose, and it makes you hungry and you eat more, I think there's something in that. I also think there's something in the fructose story. I actually think that, I think the evidence is mounting that fructose has this dopamine, it has this effect like cigarettes and like heroin and stuff. And so I think people do have a fructose addiction. It's addictive. I think there's something in it. But they're all parts. They're not one or the other. They're all parts. And so, and yet we do have a particular school of thought who believes it's all about fructose. And there's another group who believe it's all about glucose. And the all about fructose people saying, don't eat fruit. I mean, I read, there was something in the paper of a woman who got advice from a dietitian in the diet. It was, I can't eat fruit, I have to really restrict fruit. But most fruit's 90% water, isn't it? Or fruit is mainly water, that's the number one ingredient. Number two is fibre, and somewhere down the list is a bit of fructose. And this is the whole food, yeah. We're kind of digressing, but that's fine. That's good. I think they're all important. Well, moderation is, moderation is interesting, but I was reading a history of butter in New Zealand. And in the 1930s, it was people encouraged to eat a pound of butter a week at least. A pound of butter was thought to be. I'll come to butter later, but anyway. And outcomes. We talked about outcomes that if you can measure your outcomes blindly, or death is really quite a good outcome to measure because it's objective, or some machine. But actually, there is another. Death is a great outcome to measure. It's fairly objective, but it's rare. Death is rare. Death is rare, and I had a colleague who was one of my PhD students who's a great fructose. He believes it's all about fructose, and he looks at the randomized trials, and his view is that if you look at all the randomized trials, and if the intervention doesn't reduce the death rate, then I'm not interested. So he says he only looks at the death rates. And his argument is that everything else is prone to measurement error and everything, and really the only outcome is death.
But that death could be caused by a number of things.
Well, so there are two problems with that way of thinking. One is there are many causes of death, but the second reason is that most studies are far, far, far too small to actually be able to show a difference in death, because death is a rare outcome. You often have to do extremely large studies or put all sorts of studies together. So both things. So you end up having to try to put all of the science together. You have to put it all together. Yep. I mean, we're going on. Then there's this thing. I won't go into intention to treat analysis. We talked about confounding. So this is this issue where the smokers or the drinkers, the light to moderate drinkers, did other light to moderate things. Yeah. And so the way to deal with confounding is you try to adjust, but you can never adjust properly. And you try to, and if you can do a randomized controlled trial, you try to, so we do that. We've been talking about smokers and say the drinkers, the light to moderate drinkers, but I'll give you another example. If you look at the cohort studies, when people did cohort studies in countries like the US in the 1970s and 80s and 90s, because much of the research that we have on what people eat and outcomes, the participants were recruited in the 1960s and 70s and 80s, because you need these long-term studies. So if you think back in the 1980s, can you think back? Most of you are too young, but so if you lived in New Zealand, for example, and the US in the 1980s, and you do a food frequency questionnaire, and one of the questions is how often do you eat olive oil? And if you ate olive oil, on a daily or most days in the 1980s in the US, could someone tell me, or New Zealand? Let's just talk New Zealand. If you were eating olive oil regularly in New Zealand in the 1980s, who were you? Sorry? French? Or you were an immigrant, or you were like us? Were you travelled? Yeah. You were unusual. You were unusual because certainly in the 1960s, there was pretty much only one place you could buy olive oil in New Zealand, from a chemist, and you bought it in a little vial, and it was used to soften earwax. And so, cold pressed. So until the 1970s, well, until 1973, you couldn't buy margarine because it was illegal to buy margarine. But also vegetable oil. So people, if you wanted to fry something, if it was fancy frying, you used butter. If it was everyday frying, you used the fat that you had dripping, basically. There was a Watties can sitting next to the stove, and after the roast or the chops or whatever, you just poured the fat in there, and it just sat there, and you needed something. So there were two, you could possibly go to the supermarket and buy that hard. You could buy
Soybean or Kremelka.
Well, there was something which there was a dripping, but there was, and it was. Yeah, it didn't have the bits in it that from the roast, it was refined. But it was, whatever it was, even if it had started off as a vegetable oil, it was hydrogenated. And so all the stick margarines from the 40s and 50s, well, I think margarine was first manufactured about 1900, and the process was taking, actually not always vegetable oil, even sometimes other fats, but it was hardening it by hydrogenating it, so turning an unsaturated fat into a saturated fat. By the time New Zealand got margarine, the world had changed, and our margarines were always very low in hydrogenated fats. In fact, they were kind of mainly emulsified. So New Zealand has never had those hard margarines, and yet most of what you hear from the people who don't like margarine is look at the evidence about margarine. Of course, it's not our margarines. It's not our margarines. So that's why when you look at a study, you need to look at who was recruited and when. So part of the recruitment was when was it done? When was it done? And so much of our nutrition evidence is quite old now. But going back to our I was going to say avocado eaters. I was going to say, well, that's another one. I don't know whether no one here is as old as me, but well, excited, yeah. So I first had an avocado in 1977. And it just happened that I was on a kibbutz in Israel that I had it. And my wife didn't have an avocado until after she met me, so it was 1983. So she'd never eaten an avocado until 1983, and she was educated, middle class. So I mean, it's radical. If you think of it's radical change. So if you did a study even in the 1980s, and in your food frequency questionnaire you asked about avocado eating and olive oil and stuff, that would identify a group of usually educated, health, people focused. So some of what we believe about the benefits of the foods that are probably healthy, I think the benefits are overestimated in the cohort studies because there's this other mixing. It's like the light to moderate people. And so you have to look at the stuff, you have to look at it cautiously. You have to interpret this data very cautiously. Yeah. 12 o'clock. So, okay, so we're almost there. So we're almost there, but we're doing the paper at the same time. So that's okay. So my second formula. So far you've had a picture. You've had one acronym, which was PCOT. You had one formula, which was occurrence equals events over population, which was ego and SIGO. And here's my second formula. So there are two formulas and three acronyms here. You've had two acronyms because we had Rambo Man. We had PCOT and Rambo Man. So we're almost there. So my second formula it's not really a formula, it's just a statement that random error equals 95% confidence intervals. Now, when you look at statistics, so there's two sorts of error. There's what we call non-random error and random error. And the Rambo Man ones are the non-random error. So that's all things about study design. But whenever a study is done, is that in the ideal world, we'd study everybody. We'd take everybody in the world and we'd randomise them, and they'd do what we do. But of course we can't. So what we do is we take a sample. And we do a study in a sample. We do the study in a sample. But that is one triangle from the big triangle of life, of all people. It's one triangle. And so one of the questions that we have to answer is, how closely do the results from my sample, how close are they to what's happening in the world triangle? Okay, so we're always trying to make inferences about a population based on studying a sample. So we're interested in the population, but we only study a sample. And when you take a sample, so, if that's everybody in the world, or everyone relevant to your study, so it might just be all Māori aged 40 to 70 currently living in New Zealand. Whatever your question is, whatever you say, then we do this study. That's the study we do. We just do that. And we're trying to say something about all of those people based on that study. And so when we do that sample, just by chance alone, there are going to be some differences between your sample and everybody. And the whole point of statistics, p-values and confidence intervals, is to try to relate the findings from that study to what the findings in everybody. So what happens is, in this study, I get ego and I get a SIGO. I get that. But what I really want to know is ego and SIGO. I really want to know that. And so when you see a confidence interval, what it's saying, and you've all heard of 95% confidence intervals probably, or p-values, okay? It's this, when you find a confidence interval, it's saying that there's about a 95% chance that the true value in the underlying population lies within that confidence interval. So in this study, let's say we got, I'm just going to put the number 10 and 2. Let's say we got the number 10 and 2. And what you'll see is you'll often see a confidence interval that goes from 7 to 12, and maybe in this one from 0.5 to 3, whatever. And all it's saying is that in this study we got 10 and 2, but actually the true result in the population is somewhere between 7 and 12 and 0.5 and 2. That's what confidence intervals are all about. That's what they're all about. So there's everything you need to know about statistics.
The most common example we hear is always when they have a poll. You always say the plus or minus 3%.
Yeah. So, so this would be, and it might be, 40% of people prefer John Key as the Prime Minister, and there's a margin of error from, or they might say 5%. If they said the margin of error is 5%, then it's 35 to 45. And that's what they're saying. So that's a good one. They got that result in their sample, but in the country they think it's lying somewhere between there and there. Yeah, perfect example. And when we talk about statistically significant differences, what we talk about is, and in general, and this is kind of a loose interpretation, if you've got your ego and you've got your SIGO, whatever they are, and you do a confidence interval like that, if they don't overlap, generally they're statistically significantly different. People talk about statistically significant differences if the confidence intervals don't overlap. But if they overlap a lot, then you can't tell the difference. You can't say they're any different. And that's where those things come from. Now, conceptually, that's probably all you really need to know about confidence intervals is that, because every time we measure anything, there's not only the systematic errors, there's random error. There's these two sorts of errors. Okay. And then, so we've had one picture, we've had 2 formulas and 2 acronyms. And you want one more acronym? Okay, so here it is. It's FAITH. And this is the last one, FAITH. And so, systematic review. So, there's seldom one study that's good enough. Sometimes there's only one study. Sometimes there's no studies. But what in the sort of modern era, we're more and more interested in doing systematic reviews of the evidence. Is that we want to bring all the evidence together in a particular area and combine it if we can. And it's designed mainly to deal with random error, because the one other thing I didn't say about random error is, do you know how you reduce the amount of random error? Yeah, biggest study. You do a biggest study. Yeah, so actually, that was the other thing I was going to say, is that the picture's quite useful for thinking of this. Is if that's everybody and that's your study, the confidence intervals are quite wide. But you imagine if you did a study that big, it's close to the whole population. So the bigger your study, the closer it gets to being the whole population, which means you're closer to the truth. so in a way, small study, wide confidence intervals, bigger study, narrower confidence intervals. Yeah. So, and what a systematic review does is, in effect, it takes a whole lot of small studies and puts them together in a big study. That's what a systematic review is, and I'll tell you what a meta-analysis is as well. But the systematic review is actually just going out and finding all of the studies in a systematic way, and a meta-analysis is the mathematical part of putting them together. But what happens is the gate version of a systematic review, and we will talk more about that this afternoon, is that you go look for studies. So you go find Medlines, go everywhere, Google Scholar, go find the studies, and then you select studies that you want to look at in more detail. And in a good systematic review, you make sure that you do identify all the possible studies, and then you appraise them, and you allocate the good ones to being included, and the ones who are not so good you exclude. And then you take the good ones, and if it's possible, if they're not too different, you can put them together in a meta-analysis. So this is what happens. And the acronym FAITH, which I made up, is, can you have faith in this meta-analysis? Is the question is, did they find all the studies? Did they find all the studies? Then did they appraise them? Did they actually do a proper critical appraisal to separate the good ones from the bad ones? And this might seem strange to you, is this include did they then just include the good ones? Now, has anyone ever been involved in a systematic review? No, you haven't. Okay. They're hard work. They're really good, important studies, but people sometimes spend several years searching and appraising the studies. And more often than not, they spend several years searching and they find almost no good studies. And they find it really, really difficult not to move some of these not so good ones into there, because otherwise they'd have nothing to do. They'd have nothing. And I really feel for them, but I've seen big groups do huge amounts of work, and at the end say, God, there's, we identified 1,200 studies. We ended up reading 600 or 700. There were 2 that we thought were any good, and so what happens is they say, well, they're kind of okay, and they push more and more into the included group, and then they're put together. So systematic reviews are a good idea, and meta-analyses, they're a good idea, and they're often taught as the highest quality of evidence, but crap in, crap out. They could be you end up with less random error because they're bigger numbers, but you might have a highly biased result, but almost no random error. So, and there's huge controversy at the moment, and the study that we're meant to look at this afternoon is all about which ones should be included. Which ones should be included. Now, you need to know this. It's not something. It's something that comes with experience and knowing the literature, as to knowing which ones to come in. But that's a meta-analysis. The final part was for this cross, which is interesting because many of you are practitioners. Is that I added the cross. I'll tell you in a second why I added the cross. But when the so-called evidence-based medicine kind of revolution, or evidence-based practice, or whatever, it involves asking a good question, accessing the evidence, go find the evidence, appraising it, and then applying it in practice. So these are the 4 steps, and you can use the gate frame to kind of follow the process. So if you want to ask a good question, then because every study in the literature that you're looking for has got 5 parts, your question should have 5 parts. Okay, that's the starting point. So you ask a good question. Then you use those 5 parts to decide on your search terms. And most people normally search on the sorts of participants, the exposure and the outcomes. So I'm going through this quite quickly because it's not directly relevant today, but you can use the gate frame to help you identify search terms. Then you do the appraisal, which we've talked about. We've talked about the appraisal, the PICO, Rambo and everything. And then you have to make a decision. You have to put it all together. Now this is where the X came in, because one of my students told me that, Rod, did you know that you had a triangle, a circle and a square, but you need a cross? It's funny, you said this. And I was talking to a group of orthopedic surgeons in Wellington many years ago, and I was telling them the story. And a couple of weeks later, an orthopedic surgeon emailed me and said, I worked out what your cross is. And this is the cross. And I'd already talked about making good decisions involved combining the evidence with people's values and preferences. Also, every person is different. They might have different comorbidities or social situation. Plus, sometimes it's all very well telling people to eat a certain food, but if they can't afford it, so there's a whole lot of things that come into a decision. And I had talked about these issues, but I hadn't put it in a framework. But the cross is a perfect way of putting it, is that, when we make decisions based on evidence, it's not just the evidence that goes into the decision, as you well know. Is that that evidence is one component of a decision. Now, you'll see I've got these little arrows here on each one. If the evidence shows that if you do this, it'll kill you, then the evidence becomes a really important. But if the evidence is not so strong, or the evidence is not about it's not a really bad outcome, it's just not ideal, then sometimes values and preferences have to take precedence over the evidence. So, this is what people do when they're making decisions. And, and often it's not possible to do certain things in a certain system. You might not have the funding or the regulations. So I talk about the X factor. Someone who's got the X factor, who makes good decisions or expertise, has the ability to put all those things together. The practitioner expertise is the ability to put it all together. So that's the. Yeah. How are we going for timing? What time were we going to stop?
About 9.
Just before we stop, I want to talk to you just briefly. I just want to touch on now. Some of you have been downloading some forms. There's this thing called a critically appraised topic in CATS that we call CATS, and the forms that you've got, and if you haven't got them, we'll get them sent to you. They come in a form of a 3-sheet workbook, and they're only in Excel. They don't work in Numbers, which is the Mac only version, unfortunately, just that we haven't got around to it. And on page 1 are the first 2 steps of the evidence-based process, is that there's a question, so you ask a question and you have these search terms, and it's a way, it helps you kind of go find the studies. And then on the next page is the gate frame, and I'm going to open this in a second, but down this side is PCOT, down the middle, that is the gate frame, and you can plug the numbers in, and down this side is Rambo Man. So it's designed to be done online, because we wanted it on one page, but you can't put it on one page. If you do a printout, you need a magnifying glass. But it's not too much. And then it calculates, and I'll show you, it calculates ego and SIGO, and relative risk and risk difference, and the confidence intervals. It does it all for you. It does all that. So it's designed to take the maths. It only works. It works for relatively simple studies. Well, maybe I'll show you one in a sec. I'll show you one. And then there's the apply, which is the last page, which is the apply. Oh, this is someone from Japan said that there's a gate snack, and that was a gate meal, and then someone made me a gate cake on my 50th birthday. Yeah. That was funny, but okay, so that's